Welcome to the Virtual Foundry podcast.
Hi, everybody. Welcome to the Virtual Foundry podcast. This is volume 4, episode 7. Today is Thursday, July 27th, 2023. The time is 12:22 p.m., so just past noon. And the temperature is 91 degrees Fahrenheit. Now that's 33 degrees for you Celsius users. It is a toasty day. However, I think lots of people all over the world are having very toasty days. So I certainly don't mean to complain about that. Now, today we have a special treat. We're going to be getting an update from Mr. Highball about the work that he's been doing. I'm Tricia Cease, president of the Virtual Foundry, and with me today is the one and only Mr. Highball. Say hello, Highball.
Hey, Highball, and everybody else.
That's great. Now, you've been working with metal filaments for a while now, and you've dabbled in glass and ceramic as well here and there, but you've never really done anything regular with it. Maybe in the very beginning you did, but since then there's been liquid phase sintering and more recently microwave sintering of aluminum and titanium, which is wildly interesting. And you like to do the most difficult things first. But before we talk about your current projects, take us back to the early days of your work with filament, metal, glass, and ceramic 3D printing filaments. What were your first efforts?
Yeah, so my first efforts, like you said, maybe they did start out standard, but my first efforts really started kind of before, it started with more like traditional metal, like casting, and had gotten into watching a lot of different YouTubers and other people doing like lost PLA and lost investment casting, and that's how I kind of stumbled on Virtual Foundry, primarily a consumer of YouTube and an early creator of other things which no one will ever see because those have been buried. But the small amount of YouTube content that I saw around, FFF, and I certainly didn't call it that back then. We called it just looking for metal 3D printing. The amount of content that was on YouTube was very sparse, but it was really interesting. So I think there were maybe one or two clips of Brad at a show or something showing off some copper parts that were printed and people talking about sanding. And then there were some additional users with that were showing the process with the what was it, the magic black
powder, yeah.
Magic black powder. And so it got me interested a couple, like probably a year or two before I actually pulled the trigger on a kiln. And I finally decided to do it. I didn't have really an end goal as far as what I wanted to do. It just interested me, just like with metal casting. It just interests me. And maybe I can find an application for it somewhere down the road. At least that was the thought back then. So I didn't think it would be too much of a so I went down the rabbit hole of looking for kilns and trying to measure all the things that I needed to do, and I'm trying to stay under budget as much as I can, because at the end of the day, it was a hobby. It was a hobby for me. I had a certain set of requirements that I wanted to do. I, to this day, still do everything in my garage, and if I want to be fancy, I call it workshop, but it's a garage. So starting with that's when I after pulled the trigger. There were a lot of delays with production. It was around the COVID area, so supply chain was real tough, and I just couldn't wait until my kiln finally got there. I got the filament far before I got my kiln, and so I tried out copper first because for me it was just the most affordable option, and it was one that that my kiln was supposedly able to do. And so I got that, and I was printing on an Ender 3, one of the first Ender 3s. And with the earlier coppers, it was a little harder to get through the Bowden tube and everything. Now it's totally different game with how flexible things are. So yeah, I think that's really when I first started, and when I got my printer set up and calibrated for the filament, and when I got my kiln set up and everything, I kind of did a left turn and was like, well, these crucibles out here are also so small. I got to make a bigger one. So that's when I started. I diverted from the path almost instantly and was
Yeah.
like, I'm going to make my own and you know, try to get as many parts as I can, because it, you know, with the sintering cycles and everything, you print, then you sinter, you debind, sinter. So I was trying to do everything I could to, you know, consolidate some of that time, because for me it was hobby. You know, I know the recommended path was to debind one day and then sinter the next, and I was like, nope, I'm going straight. I'm going to do it all in one cycle, and so that's kind of where I started. So, but copper was the first one that I really got into, and really just had a lot of fun with it. First, just started kind of printing some different minis that I played tabletop games with, to be
Yeah.
honest with you. And that was, I think and then I started trying to just challenge myself as far as that process. So yeah, that's probably early days how it got started, and kind of snowballed from there.
Yeah, you've done a few things since then, and you have a very robust YouTube channel that's Mr. Highball, and we'll take a look at that in a second. And in those videos, or the earlier videos that you posted, you do show the process of making your own crucible. So if people wanted to check that out for reference, if they wanted to start doing that themselves, you do
Yeah, I
show
showed the
what you use and how you did it. Yeah.
and whether it was great for YouTube or not. I mean, YouTube is really just a way for me to, you know, keep accountable to myself. At least that's how it started, so that I can kind of record my progress, and to fill that gap that I kind of came across whenever I was looking for metal 3D printing, and I didn't see, you know, a lot of content out there. So that was my answer. Said, well, if I'm interested in it, then probably other people are. And the one thing that I hope to stay true to is I like to show my failures and successes, and I like to show you how I got there. And that sometimes isn't great for YouTube, because, well, with that you get a lot more content that you have to wade through. And you know, when you see failures, some people are like, why is this not working? And
Yeah.
you know, why are you showing this failure on here? And you know, to me, I think it's important. And at the end of the day, it's for me. And you know,
Yeah.
if there's some benefit for everyone else, then maybe they can find that there too. So
Yes, you have a very strong development focus, a very high tolerance for experimentation, but you clearly know that every failure teaches you something that informs the next process.
oh
So
yeah,
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 watching your
I just
process unfold on YouTube, it's you can watch the path of your learning, and you explain what you learned and then how you're applying it to the next one. So we can see the whole development process unfold right in front of us, really.
and I've learned a lot. It's you know, I'm a software developer by trade, so I have no business being in additive manufacturing land, but it's so interesting to me. And when I tackle a problem, I don't just want the answer. I want to know why that's the answer, and I want to know if it's the best way to do things, and if there's a better way. My kind of mantra, at least for some of these things, is how can I make this process either quicker, more accessible to people, cheaper. You know, again, I'm working at a hobby level budget
Yes.
still, so anything that can reduce the barrier to entry, to me, I think is a cool win, because I just want to see what people do with the stuff, and you know, hopefully try it out too. So again, just more of a learning thing for me.
You mentioned this being a hobby, and that's one of the things that's so awesome about additive manufacturing, is that it's available to everybody. So I could not go be a software developer this afternoon, but I could 3D print something.
You could be a software developer if you, it takes a lot. I mean, it's a lot. It's a lot to do, and that's with anything that you're, you know, you're interested in too. I mean, with I could go pick up woodworking, and whether I just like to whittle wood or if I want to cut, you know, some things, at some point that might become really useful to have a woodworker, or it might be
Yes.
very useful to be able to make a metal thing. And in this world where, you know, supply chain is challenging, or for makers who are just interested in trying concepts, having a universal tool, just a single tool to print a thing and to make it in whatever material you want, I think that reduces the barrier for lots of things.
Yes.
So it's very interesting to me, and I think there's a lot of benefits for people out there to at least dabble in it, because it's a low, and all you need is a printer.
Yes.
To start. I mean, if you can send it out to a sintering service if you want, but at least with the microwaves, maybe everyone has a microwave, so maybe that gap can be a little closer than what it has been.
So let's talk about that microwave, and I'll add a disclaimer here. Do not use your food microwave for what we are about to talk about, right? You would get a second one. But
Yeah.
let's take a look at we're just gonna take a look at the home screen of your YouTube channel and talk us through today's efforts. What's on your development bench? What have you been working on?
Yeah, so these recent ones kind of relate back to some efforts trying to sinter titanium, and my earlier effort to sinter aluminum. When I embarked in microwave sintering, it was just a proof of concept. Everything was 3D printed. The microwave kiln was 3D printed with
Yep.
Elements that you guys supply, the silicon carbide, to collect that heat during the microwave. So everything was just kind of produced at a very small scale, and just to see what I could do with it. And it's evolved from starting with like a regular metal like copper or something, like you mentioned before. I like a challenge, so aluminum is a traditionally very difficult metal for sintering and even welding for that, but because of its high reactivity, and its the oxide is very tough to break. So when I found some early success with aluminum, it got me thinking, and that's what I went with, and I just ran with it. And same thing with titanium. It's a higher sintering temperature, closer to stainless steel, but it's also very reactive, and so you couldn't just pop it in a traditional kiln without either under vacuum or under certain conditions, whether it be nitrogen or hydrogen.
Yes.
All of which I don't have. So that's what's shown here. Right here is can this be applied to these more exotic materials like titanium that that could allow you to print something biocompatible, or could be used for anything that has like a high corrosive environment that you need, which is why these metals are highly used in aerospace. So your aluminum and your titanium, both, they're very, very useful in these niche operations. And maybe if the again, barrier to entry, if it's lowered, maybe we can start seeing that in other applications, and not just by multi-billion-dollar companies that have the money to
Yes.
deposit with very expensive machines.
And being
so
able to additively manufacture titanium, which is a very expensive material to get out of the earth, you are eliminating all of that waste that comes from the machining process or the subtractive manufacturing.
Yeah, and I've never been an advocate for saying that we should get rid of, this isn't a way to get rid of those other methods. It's a way to supplement that. This is just another tool in the tool belt, and there are things that all, whether it's conservation of the environment or just material cost, that's a big thing. But also there's things that you can't do with some technologies. So you can't print a part that has infill that's less than 100% with subtractive. So you're not gonna, you could produce parts that are using this lightweight material, but are even more optimized for your application, because you don't have to print at 100% infill, and you can print organic shapes a lot easier through topology optimization. So putting my software hat on again, it's only a matter of time until we have some pretty good options that the open source community might contribute towards this topology optimization. I mean, things like SolidWorks and other, in topology, I think is another one. They have commercially available products, but give it another year, give it 2 years, someone's gonna produce something, and now the ordinary maker can build some optimized bracket for something that I've never even considered, and that's cool.
Yes, the objects and the things around us are going to start to look different as we go on down the road here. So we've been talking about microwave sintering of aluminum and titanium. Tell us about that process. How does that work? Why aren't you blowing up?
Yeah. So again, not blowing up because the powder is encased around with a ballast, just like, so that's going to be the insulating layer. And as well, there's a double wall layer of alumina, which is the crucible supporting. So now I'm not going to say it's not without its dangers. So a little asterisk
Yes.
there, without monitoring. The challenges with the microwave, you have two things. You have what's your power level and how long you're going to zap it. So the walls of the crucible and the ballast can't interact with the microwaves. Otherwise, you're going to be heating up the wrong spot or develop these standing. So the phenomenon is called standing waves. There's always a section inside of your microwave that is going to be more concentrated than the others. So that's why you generally have the rotation. I'm not doing that though because of the heat. So why I'm not blowing up is because I've taken precautions to support the parts and to encase them in an insulating layer and to put a layer of fire ceramic blanket underneath and surrounding the areas that would otherwise be susceptible to heat. But microwaves have metal in them. They're made of metal. So, it's a possible, whether they reflect or absorb, that's the thing that you have to you be worried about. And you're not going to go put a fork in the microwave just raw because those little points cause arcs. So the arcs are the dangerous part. And really the biggest danger is frying your microwave, and probably bigger than that, catching your microwave on fire. So nothing's going to blow up from within the crucible as long as you have it supported and protected.
So even though
long-winded way to say that.
Even though you're using a standard household microwave, you're still following that same basic 3-step process, the print, and then the debind and sinter. So instead of a kiln, you're using a microwave, and to amplify the heat, so rather than the heating elements being in the kiln, you're creating the heating elements actually within the crucible. Now, this tool or this crucible with heating elements in it is called a microwave kiln.
Correct.
You've sort of confused the issue.
To confuse the issue.
Yes.
Yeah, it's the kiln, but it's really just, you can call it whatever you want. It's a box that gets really hot on the inside rather than a box that heats things that are inside of it. So, it's a little different than, it's not too far of a stretch, I don't think, for people to realize it's still doing the same thing. The microwaves aren't zapping the part per se to get it hot. They're zapping the heat susceptors, which are doing the heating of the part. So there's still traditional, ramp rates, maximum temperatures, those type of things that otherwise you'd have to program in your kiln controller. You can do that same thing with a microwave and with a microwave kiln. You just have to do it in a slightly different way.
Yes, so you're still debinding at around 480 Celsius, 900 Fahrenheit, and then going up to the standard sintering temperature for whatever
sintering temperature for whatever the material is. And the big benefit, and I'll say a big benefit first and then the downside second. Big benefit is that it's faster. It's just a lot faster than a traditional kiln, so there's less waiting. And I know that when it gets up those upper temperatures, my kiln really struggles to go at a good ramp. So the downside is it's less controllable. You can't, there's no way to just put your schedule in a microwave without hacking the microwave together with a controller or PID or something like that, and putting some, and it's not that I haven't thought about doing that. It's just trying to keep this accessible. It can be done without a modified microwave. It's just those are some of the considerations to take when you're doing it.
So you have some work to do before you start, and that is figuring out what temperature your microwave gets to at what power. So there's this whole calibration sequence that you do.
Yeah.
We do have information about that on our website in the blog section. If you go to our website and search microwave sintering, you'll find that. And there are some clues or instructions on how to calibrate your microwave and see what it will be capable of.
Yeah, and to put it in perspective, I have 3 microwaves. They're all stacked up on top of each other, and they're from lowest power 600 watt to highest, which is 1100 watts. So, and I have a 900 in between. Not saying that you need 3 microwaves. It's just that the top level 600 watt is fantastic for debinding because it can't ramp to the same temperatures that my 1100 watt can, and it frees up the 1100 watt for if I'm doing 2 things at once. So if anyone's interested in doing that, something to consider when you're looking for microwaves. But you don't have to buy a fancy one. 2 of my microwaves are under $100. So, and you can get them used. In fact, I recommend you getting them used. You just have to do a little cleanup, probably on the inside first.
Again, don't use the same microwave that you're heating up your hot pockets in.
Correct.
So we know that using a standard kiln, the process is 2 days. You're going to debind 1 day, sinter the next day, and that can be pretty lengthy. And you talked before about wanting to really compress that process, which brought you to the microwave system. What is the longest, I guess, debind sinter cycle that you've experienced using the microwaves, or what is this typical length of time that you're seeing as you're
I'm doing small parts for testing and also for conserving the material. But with a somewhat closed crucible, and again, this kind of goes back to the things that I've made. I have a lid surrounding it. It's well encased, and the elements hold the heat very well. But the lid I do for debinding has small pinholes because you want some of that gas to escape. But otherwise, I'm trying to keep the heat really contained on the inside. So while I may debind for less time than what you probably do in a traditional kiln, it also keeps the heat in. So just resting outside of a microwave is still debinding. If that, it's still working. So, I've done a couple hour debind where it's take it out of the microwave, put it back in with the addition of ceramic fire blanket inside of the internals of the microwave. It really protects I constantly measure the heat of the outside, the inside of the microwave as I'm doing these, but I've been able to run at a full sinter with the maximum time that my microwave can do on its digital display, which is 99 minutes in one burst. So I've been able to keep it in there, take it out for a small amount of time, let it cool, and do another 99-minute burst. There's I haven't had any issues doing very long, multi-hour processes. What my limitation is that I normally do it at night. And at 3 a.m. normally is when I'm like, maybe I should probably pack up pack up shop. So I've done upwards for sintering of about a 4-hour sinter before, using 1 to 2 microwaves, and I've had no issues with my hardware.
Wow, great. And that's a dramatically reduced time.
Yeah.
The standard,
but again, small parts. Yeah, small parts. And bigger parts need longer, times, different constraints. So it's a learning game, and the more people doing it, the faster we get there. So
so let's add some caveats and disclaimers that you have you've made this a very strong focus. You haven't entered into it lightly. You've done a lot of research, you've done a lot of trials, and you've had a fair amount. Well, I'll say that you've probably had the most experience with this technique and this material in the world. So congratulations.
Thanks. Maybe I might.
So not to be entered into lightly, especially the aluminum and titanium things. But after we did a webinar together about microwave sintering, and after that webinar, another partner innovator reached out to us showing us some copper parts that they had successfully microwave sintered. So it's an exciting field. Now, we talked about those microwave kilns, and that's the crucible with the heating elements inside of it. That is a commercially available product. If you go to Amazon and search for microwave kiln, you'll see those. Highball,
Yeah.
you're making your own, but that also is a commercially available product if people wanted to try that out.
Yeah, people want to try it out, by all means. I think there's some benefits to the way that I'm doing it, but I don't, I don't know. I mean, maybe you could get really great results with the $40 Amazon. I'd say it's a low barrier entry to try, as long as you take the proper considerations. And same thing with any kiln. You're not just going to do it in a closed, environment. You want to have good ventilation.
Yeah.
You want to monitor your hardware. You want to make sure nothing's sparking. I've had some cases where, some silicon carbide heated up so much that it burnt through, pinholes in my crucible. So that means it's getting upwards of like 3,000 degrees Fahrenheit. So you want to make sure that you take your, proper considerations, just like you would with any other, dangerous thing. And the other asterisk, I take no responsibility for anyone blowing up or burning anything down because something wasn't, this is, again, highly experimental.
Yes.
Make sure you do a lot of research. Where there's off gases of dangerous things that you want to, definitely not breathe in. So heavy caveat, but
yes.
With that all being said, I think there are people out there who can take those precautions, who understand the risks and are interested in, additive at this cost point or anything like that, or maybe just for the materials that they're that are otherwise unavailable in their traditional kiln setup. And I think there's definitely room for support of individuals like that.
So I will echo the sentiment, not necessarily to be entered into lightly.
Yes.
You will have to do a lot of work in calibrating your microwave, and I'll put a link to those instructions in the description of this video. And just really understanding what's happening, understanding the debine and sintering process. So if it's a road you want to go down, don't start with aluminum and titanium. Start with something simpler like copper or bronze, and do the research, put the time in to really understand what's happening.
And make a YouTube video. I'd love to
Yes.
see some other some results out there. That'd be cool.
Now, you get lots of comments on your videos, and you're very responsive to those comments. So that is one way that people can find you. How else can people find you?
I'm also part of the just Virtual Foundry Discord. So pop in over there and ask your questions, and maybe we can chat. YouTube's a good one. I do post kind of sometimes on the Virtual Foundry subreddit.
Yes.
But other than that, those are the places. So
okay, super.
Yeah.
Highball, I really appreciate your work. It's really fun to watch you work, and you are also very fun to know and to talk to. So I appreciate everything that you're doing. It's just fun to watch.
Thanks. It's been a lot of fun for me too.
Now, I do have one more very important question for you before we wrap up today.
Oh boy. I think I know where it's going.
Did you hear about that person who was afraid of jumping a hurdle? Oh, they got over it.
Oh, I get it.
Yeah. Well, hey, out there, if you have a cool project that you'd like to showcase in this format in one of these podcasts, reach out to me at info@thevirtualfoundry.com. If you've got a topic or a question you'd like us to do a deep dive on, same info@thevirtualfoundry.com. I would love to do a podcast with or for you. Like and subscribe the video on YouTube. Check us out on all your favorite social medias, YouTube, Instagram, Facebook, LinkedIn, TikTok.
GeoCities?
No GeoCities, no. And check out the website. There's a ton of information there, and the Virtual Foundries YouTube channel. You'll see links to all those in the description of this video. Highball, thank you very much for joining me today. Always fun talking with you.
Thank you very much. Drink some coffee.
That's going to be in the blooper reel.
That's fine.